On October 19, 2017, astronomers in Hawaii made a remarkable discovery. Using the Pan-STARRS 1 telescope, they detected a faint, fast-moving point of light that stood out against the familiar backdrop of stars. At first, it seemed like just another asteroid passing through our solar system, but something about its speed and trajectory immediately caught their attention. Careful analysis revealed that this object was traveling on a hyperbolic path, meaning it wasn't bound to the sun and had come from far beyond our solar system. This was a truly extraordinary find, the first confirmed interstellar object ever observed by humanity, a cosmic visitor from another star. The object was later named Oumuamua, a Hawaiian word meaning a messenger from afar arriving first. Its discovery sent shockwaves through the scientific community, igniting excitement and curiosity worldwide. Almost overnight, astronomers around the globe mobilized, racing against time to observe this mysterious traveler before it disappeared forever into the depths of space. Telescopes worldwide scrambled to capture every possible glimpse, coordinating efforts and sharing data in a rare display of international collaboration. We had only a matter of days to gather as much information as possible, making every observation critical. Scientists worked around the clock, analyzing data and debating theories about its origin and nature. What we found was perplexing. Oumuamua didn't behave like any known comet or asteroid. Its motion, speed, and even its shape were unlike anything we had ever seen before. It was small, dark, and reddish in color, with a strange, elongated shape. Its behavior defied our expectations, leaving scientists puzzled and intrigued. The more we studied Oumuamua, the stranger it seemed. Its rapid rotation, lack of a visible tail, and unusual acceleration challenged everything we thought we knew about celestial objects. Oumuamua's brief visit sparked intense debate and speculation, a mystery that continues to echo through the halls of science, inspiring new questions about what else might be out there, waiting to be discovered. The first mystery that caught astronomers' attention was Oumuamua's unexpected acceleration as it sped away from the sun, something that simply couldn't be explained by gravity alone. This was the first clue that Oumuamua was no ordinary visitor. Normally, when comets approach the sun, they heat up and release gas and dust in a process called outgassing. This creates a bright glowing coma and a long streaming tail, and the force of this outgassing can push the comet, causing it to accelerate. But Oumuamua was different. It showed no signs of a coma or tail at all. The Spitzer Space Telescope, one of the most sensitive instruments for detecting heat and gas in space, found no trace of dust, gas, or water vapor. None of the usual signatures that would mark a comet's passage. It was a paradox, accelerating like a comet but looking nothing like one. The object defied every expectation astronomers had for interstellar visitors. Its motion was also bizarre. Instead of spinning smoothly, Oumuamua tumbled chaotically through space, flipping end over end in a way that's rarely seen among long-traveling space objects. This wild tumbling caused dramatic changes in brightness, with the object's light fluctuating by a factor of 10 as it spun. Such extreme variation is almost unheard of for natural objects. These brightness changes suggested that Oumuamua had a highly unusual shape, far more elongated than anything seen before. It couldn't be round or potato-shaped like most asteroids. The data pointed to an object at least 10 times longer than it was wide, possibly shaped like a cigar, or even a flat pancake. No known asteroid or comet in our solar system matches this extreme aspect ratio. Oumuamua stood apart from every catalogued object. The combination of unexplained acceleration, lack of outgassing, and its extreme, never-before-seen shape made Oumuamua a true cosmic oddity, something that challenged the very definitions astronomers use. Each new observation only deepened the mystery, as every attempt to fit Oumuamua into a familiar category failed. Scientists were left with more questions than answers, debating theories late into the night and searching for clues in the data. In the end, Oumuamua refused to fit any familiar category, remaining a solitary enigma, drifting through the vastness of space and leaving us to wonder what other cosmic curiosities might be out there, waiting to be discovered. The wild brightness swings led astronomers to imagine Oumuamua as a giant cigar, long and thin, tumbling through space, but further analysis suggested it could also be a flat, pancake-like disk, flipping like a coin. Both shapes were unlike anything seen before, and hard to explain with natural processes. How could such an extreme shape form and survive a journey across interstellar space? Some speculated it was a fragment torn from a larger body, but even that didn't fully explain its form. The pancake model, in particular, raised a radical idea. What if Oumuamua was shaped like a solar sail? A thin, flat object could be pushed by sunlight, explaining its acceleration without outgassing. This possibility opened the door to even more extraordinary explanations. Was Oumuamua a natural oddity, or something engineered? Faced with Oumuamua's anomalies, scientists split into two camps. Most searched for exotic natural explanations: a hydrogen or nitrogen iceberg, a crusted-over comet, or a fluffy dust aggregate. Each theory tried to fit the data, but all had major flaws, requiring unknown formation processes or unlikely survival across interstellar distances. A minority, myself included, considered a bolder idea. What if Oumuamua was artificial? A solar sail, designed by an alien civilization, would be thin, flat, and accelerate from sunlight, matching the observations. This hypothesis, though controversial, fit the facts more simply than many natural models. The debate grew heated, with strong arguments on both sides. Some insisted nature must have an answer. Others argued we shouldn't dismiss the artificial possibility. The mystery of Oumuamua became a test of scientific open-mindedness. The search for answers pushed planetary science into new territory. The debate over Oumuamua's origin exposed a deeper issue: science's resistance to paradigm-shifting ideas. The alien artifact hypothesis was often dismissed as sensationalist, and its proponents faced criticism beyond scientific arguments. This isn't new. History is full of revolutionary ideas initially ridiculed, from plate tectonics to adult neurogenesis. Many scientists admit to self-censoring to avoid controversy or career risk. The Oumuamua case became a textbook example of this resistance. Yet, the scientific method demands we follow evidence, not consensus. With Oumuamua gone, we can't collect more data, so the mystery endures. The only way forward is to find more interstellar objects and study them with open minds. That's the mission of the Galileo Project, to search for new cosmic messengers and analyze them without prejudice. Years after Oumuamua, astronomers waited for another interstellar visitor. On July 1, 2025, Atlas detected 3I Atlas, the third confirmed interstellar object. Unlike Oumuamua, 3I Atlas displayed a classic cometary coma and tail as it neared the Sun. Its behavior matched expectations for a natural comet, providing a perfect comparison. The global scientific community quickly agreed. 3I Atlas was a textbook interstellar comet. Its journey, composition, and ancient origins made it a fascinating object in its own right. Yet, its normalcy only highlighted how strange Oumuamua truly was. Even as 3I Atlas was studied, the shadow of the Oumuamua debate lingered. 3I Atlas gave us the comparison we needed. It behaved exactly as an interstellar comet should: visible coma, predictable acceleration, modest brightness changes. In contrast, Oumuamua had no coma, unexplained acceleration, and wild brightness swings. 3I Atlas proved that not all interstellar objects are as strange as Oumuamua. This deepened the mystery. Why was our first visitor so unique? The odds of detecting the rarest, strangest object first seemed slim. For some, 3I Atlas validated the idea that we can recognize natural interstellar comets. For others, it made Oumuamua's anomalies stand out even more. The puzzle pieces didn't fit. More data led to even bigger questions. The mystery of Oumuamua only grew sharper. Between 2023 and 2025, new analyses kept the Oumuamua debate alive. The hydrogen iceberg theory was undermined by calculations showing such objects couldn't survive the journey. Nitrogen and dust models also struggled to explain the data or their rarity. Each natural explanation faced tough scrutiny and often fell short. The discovery of 3I Atlas, a normal comet, made Oumuamua's uniqueness even more striking. If such objects were common, we'd expect to see more like Oumuamua, but we haven't. This shifts the odds, making the artificial hypothesis more plausible. the enduring questions remain. What was Oumuamua, and what does it mean for our place in the cosmos? The mystery of Oumuamua, sharpened by the discovery of Three-Eye Atlas, stands as a profound lesson in scientific humility. These enigmatic visitors from beyond our solar system challenge our assumptions and remind us that the universe is far stranger than we often imagine. True progress in science comes not from ignoring anomalies, but from confronting them with open-minded curiosity. When faced with the unknown, we must resist the urge to retreat to comfortable explanations and instead embrace the questions that push the boundaries of our understanding. The upcoming Vera C. Rubin Observatory, with its cutting-edge technology and sweeping sky surveys, will soon detect dozens of interstellar objects each year, far more than ever before. This new era of discovery will transform our knowledge of the cosmos. This flood of data will help us answer a fundamental question. Was Oumuamua a rare, one-of-a-kind visitor, or just the first glimpse of a vast, hidden population of interstellar wanderers passing through our solar system? If we find more objects like it, we'll be forced to rethink our theories of cosmic formation, planetary systems, and the processes that shape the universe on the grandest scales. But if such objects remain elusive, the case for an artificial or extraordinary origin only grows stronger, inviting us to consider possibilities we once thought impossible. Our responsibility as explorers is to follow the evidence wherever it leads, setting aside our preferences and preconceptions in pursuit of the truth. Oumuamua's story is about more than a single object. It's about our willingness to ask big questions, to challenge the limits of our knowledge, and to remain humble in the face of the unknown. Its brief passage through our solar system changed our perspective, reminding us that the universe is full of surprises waiting to be discovered. We are just at the beginning of our cosmic journey, standing on the threshold of discoveries that could reshape our understanding of existence itself. The next great revelation could arrive at any moment, from any corner of the sky, challenging us to think bigger and dream further. That's why we must keep our eyes and our minds open to the sky, ready to embrace whatever wonders the universe has in store.